All right, these should be your notes for it's in the system investigation 1. Okay. So first big idea is, how do you graph a linear equation written in, let's first look at slope-intercept form. Okay, so that's going to be like y equals mx plus b form. Okay, so, and this is the type of linear equations you've been graphing since 7th grade, where m is actually your slope. In your b value, you can find the y-intercept. Okay, and your slope is found, that m value, you can use the rise over the run to help you get some points. Okay, so let's go ahead and, so we're just kind of thinking about the sort of the general form. If I making a graph, the first thing I'm going to plot is whatever my b value is. So it's somewhere here. Okay, and then from that point, I'm going to use my rise, and then however much that is in my run, that'll give me another point. I'll use the same rise and then run to get another point, and then my equation is going to connect those things. Okay, so b value, and then rise and run. Oops, rise and run. All right, let's look at an example of that. So let's say we've got y is equal to 2/3 x plus 1. Okay, so I'm going to make a graph of that. First thing I'm going to plot is my y-intercept at 1. So 0, 1, this value right here. And then I'm going to move, I'm going to rise 2. So 2 is my rise and 3 is my run. So from that point, if I go 2 units up and then 3 to the right, 2 and then 3, that will give me that unit rate of having my line actually increase by 2/3 each time. So I have to really go over 3 until I increase a full 2. But my unit individual rate is it's going up by 2/3. Okay, so now we've learned a new type of linear relationship that we can also graph, and that's an equation that might be written in standard form. Okay, so how do we graph that? That was, oops, okay. So standard form, we've seen like with the caps and t-shirts problem, and like the homework problem about dimes, and oh goodness, the speaker's not coming on. So let's say we've got ax plus by equals c. So on that one, standard form, the x and the y end up being on the same side, and a lot of word problems end up fitting more naturally into that format. Okay, so we've got a couple options on how to graph that. We could just try and convert to slope-intercept form. Okay, and I'll go over how to do that on the next page, but basically we could kind of convert it into one of these. Okay, or the quick way to graph it in this form is to find the x and y intercepts. Okay, and those will be the 2 points that you could then find. Okay, so, and how do you find the x and y intercepts? Okay, so to find the x-intercept, that happens, the x-intercept happens when your y value is 0. Okay, so you basically figure out when you make y 0, what that x value needs to be. Okay, so you end up making y equal to 0. Okay, set that equation up and then try and solve for x and see what you get. The y-intercept happens when x is equal to 0. Okay, so you go ahead and replace x with 0 and solve that equation then for y. Okay, so that's going to be like your 0 y point. And then you just plot both of those. Okay, let's look at an example of that. let's say I have 2x plus 5y equals 20, and I want to graph all the pairs that work in here. Okay, well, I can get enough that I can see what that graph looks like by just finding the x and y intercepts. Okay, sometimes it helps to make just a little tiny table. Think about when x is 0, what's y? And when y is 0, what's x? So if I make x be 0, if I put 0 in for x, 2 times 0 is just 0. So sometimes students will just kind of cover that part up. And then the equation I'm left with to solve is 5y equals 20. Well, 5 times what is 20? That's 4. Okay, how about if y is 0? If I plug 0 in here for y, 5 times 0 is 0. So I'm kind of left with just this equation. 2x is equal to 20. Well, how could I solve that? 2 times what is 20? That's 10. Okay, so and then I could just go ahead and plot those 2 points, and then I'm pretty good. Okay, so now this is going to kind of go off my graph, so maybe I'll go up by 2. So when x is 0, y is 4. So this is 0, 4. And then when x is 10, so I'm just going to go by 2's again. So 2, 4, 6, 8, 10. 10, 0. Okay, and then I can go ahead and just connect that. And then that would give me some other pairs that work too. Anything along that line would also be a solution to this. Okay. All right, so next big idea is, how do you symbolically convert? Okay, let's first do standard form to slope-intercept form. Okay, so let's go ahead and just try one, and then we'll take some notes on what we're doing. Let's say I've got 2x minus 5y equals 10, and I want my equation to, instead of having the x and y on the same side, to be in that y equals form. Okay, well, what's keeping y from being alone? It's got this minus 5 here and also this 2x. Okay, so usually what we'll do is we'll subtract the x value from both sides. So I'm going to subtract 2x off of here, 2x off of here. So when I subtract 2x from 2x, that's gone, and I'm left with negative 5y. Now when I subtract negative 2x from 10, I really can't subtract those two things because, well, or at least I can't write it as one term because it's not like it's 10x, so it's not going to be 8x. So basically, I'm just left with 10 minus 2x. I could change it to 10 plus negative 2x. I'm going to go ahead and put the negative 2x first and then say plus 10. So that's what I would have over on this side when I combine those two things together. Okay, and then I want to know what y is, not negative 5y. So to get rid of the negative 5, I'm going to divide this side by negative 5. And then I actually have to divide both of these things by negative 5. So if you kind of remember when we talked about that in class, like if I've got, say I've got 5 plus 10 equals 15. If I divide this side by 3, this is going to be 5. Well, what should I divide? Pick another number. If I divide this side by 5, this is going to be 3. What would I need to which of these should I divide by 5 so it still equals 3? Well, I'd actually have to divide both of these things by 5. So when you're working with equations, if you decide to multiply or divide, you actually have to divide each of the terms or multiply each of the terms. So I'm going to divide both of these things by negative 5. Okay, so then I get y is equal to, and then since I'm kind of want it in slope-intercept form, and I want the slope, a negative divided by a negative is a positive, so I'm just going to make this 2/5, keep it as a fraction, x, and then I'm going to go ahead and take 10 divided by negative 5 and get negative 2. And I could convert that to a decimal if I want, but I could also just leave it like that. Okay, so now I've got my slope and my y-intercept. Okay, so basically what was my strategy? The first thing you're going to do is you're going to subtract the like AX value from both sides. Okay, and then after you do that, you're going to divide both sides by the coefficient. Okay, and that's just the number that's being multiplied by y, so the coefficient of y. Okay, just the number in front of y. All right, so that's how we go from standard form to slope-intercept form. Okay, how about if I want to go from slope-intercept form to standard form? Okay, so on this one, I want to get the x and y to go on the same side. Okay, so let's say I've got y is equal to 5x plus 2, and I want the x and y to both be on the same side. Okay, this is pretty easy. All I have to do is remove the 5x from this side by removing it on both sides. So I'm just going to subtract 5x from both sides. Okay, I can't combine those because they're not like terms. So I'm just going to write negative 5x plus y is equal to 2. So now I have the x and y on the same side. Okay, so basically you can do this in one step. You just have to subtract the mx value from both sides. Okay. All right, so then the last thing we talked about this with this first investigation, number 3, was how do you find a common solution to two linear equations graphically. Okay, so basically your strategy is just going to be to graph both of them and see if you can figure out where they intersect. Okay, well, let's do this with an example. Okay, let's say I've got, y is equal to negative 4x plus 1, and I've got 4y minus x is equal to 4. Okay, so let's give us a little practice of looking at these two types of equations. Okay, so I'm going to graph the first one. This is in slope-intercept form. So I'm going to put my y-intercept at 1, slope of 4, so over 1, down 4. Over 1, down 4. Okay, just trying carefully. Probably should use a ruler here. Okay, so that's that first line. Oh gosh, I've done that a little better than that. Okay, so and then I'm going to graph my second one. This one's in standard form, so I'm going to try and use that technique of x and y. X is 0. So if I make x be 0, I'm going to cover the x. Y would have to be 1. If I make y be 0, cover the y. The opposite of what is 4? That would be negative 4. So I'm going to plot the point 0, 1 right here and negative 4, 0. Okay. I'm going to go ahead and connect those points. Okay, so and then the solution graphically is just where these two lines intersect. Okay, so my common solution is 0, 1. If I make x be 0, y will be 1 in both this equation and this equation, and that's the only solution that they have in common.